Hello, let's look at some examples of ratio and proportion which will help us solve a lot of different types of questions.
Three travelers meet together for a meal. The first one has 2 cakes with him, the second one has 3 cakes, and the third one has none. They share the cake equally, and the third one pays ₹6 for his share. What is the share of money that the first person gets? So totally they have how many? 3 with the second one, 2 with the first one, so 5 cakes, which is shared across 3 people, so everyone gets what? 5 upon 3 of a cake. So the third one is actually giving ₹6 for 5/3 of a cake. So for one cake, how much does it cost? 6 divided by 5 by 3, which is nothing but 18 upon 5. So 18 upon 5 is the cost of one cake. Now let's look at how much does A eat and how much does A give. So A has what? 2 cakes with him. He had 5 by 3. So what is left? A 2 minus 5 by 3, which is nothing but 1 by 3. So one cake costs 18 upon 5 and he gave away 1/3 of it. So 18 upon 5 into 1 by 3, which is 6 by 5, which is nothing but 1.2 rupees. So he ended up getting 1.2 rupees, whereas B, or the second person who had 3 cakes, would get 4.8 rupees. Let's look at another example. This time it is completely different. A dog pursues a cat. Now a dog is running after a cat and takes 5 leaps for every 6 leaps of the cat. 4 leaps of dog are equal to, in terms of distance, 5 leaps of cat. Compare the speed of dog and cat. Now first of all, there is a dog and there is a cat. They are running at different, the dog takes 5 leaps at a time and the same time cat takes 6 leaps. The distance of 4 leaps of a dog is equal to 5 leaps of cat. Completely different things. How do we equate? Let's get them down to one basic. Let's get them down to a cat or a dog. Let's take cat. So 4 leaps of a dog, which is in terms of distance, is equal to 5 leaps of cat. So how much is 1 leap of dog? 1 leap of dog will be 5 upon 4 leaps of cat. If 1 leap of dog is 5 upon 4 leaps of cat, what will be 5 leaps of dog? So that will be 5 into 5 upon 4, which is nothing but 25 upon 4 leaps of cat. Now this is what the dog covers in 5 leaps. So 25 upon 4 leaps of cat. In the same time, cat takes up 6 leaps. So if you look at dogs, it is 25 upon 4, which is the distance covered in the same time that the cat covers 6 leaps of his. So 25 upon 4 is to 6, which is nothing but 25 is to 24. Now that is the speed of dog is to cat. So dog is at 25, cat is at 24. Slightly tricky, but still it was not that difficult. Let's look at another one. The height of Raman varies according to the square root of his age. What will be the height of Raman at the age of 7 years if he is 4 feet tall at the age of 9 years? Now height is directly proportional to age. H is equal to K. Let's take K as the constant. I know it is not equal to age, it is proportional. So K is a constant that we multiply. So H equal to K into root of age. Let's take the initial one, 4 feet at the age of 9 years. So 4 is equal to K root of 9. So that gives me K as what? 4 upon 3. Let's put it in the new equation. H is equal to 4 upon 3. Now K's value is being put in into root of 16. That was the original formula, the root of age. So at the age of 16 root is 4. So 4 into 4, 16 upon 3 gives me 5.33 feet. This is nothing but 5 feet 4 inches.
We've just seen how ratio and proportion is used to solve problems from 2 to 3 different types of applications. However, there are many more applications of ratio and proportion. One of them being time and work, time, speed, distance, and so on. But if you look closely, ratio as well as percentages are different types of comparisons, and these are used intermittently across wherever the calculation source requires.